So when we're looking for the y-intercepts, we have to think about what we used to do before. So when we had a line and we wanted the y-intercept, we would let x equals 0, and then we'd find our number, and it would give us this value that was on that line there, right? So guess what we have to do for our parabolas? So anytime we have a parabola or a quadratic form or something that we want to use, here's what we do. For the y-intercept, here's what we do. We let x equals 0 in our standard equation. y is equal to ax squared plus bx plus c. So that means we got y is equal to a times 0 squared plus b times 0 plus c. What the heck? So in this case, 0 times anything gives 0, so that's gone. And this goes away as well. So in the end, we always have the c value. So this means the y-intercept is the constant term. So otherwise, we always just have to let equal 0 and find our answer. Okay? Now, for this basic form, here's what we do. For part B, it says, what's the y-intercept? Let's write that out. B, what is the y-intercept? Now, you can do what we did over here by letting x equal 0 and finding the c value, right? And it will work all the time. Now, if you don't want to do that, you just look at our basic equation. So here's what we'll do. So there's two ways to find it. Two ways. One, you let, so for y is equal to x squared plus 2x minus 15, we let x equals 0. So now you've got y is equal to 0 squared plus 2 times 0 minus 15, right? And then you end up with 0 going away, and 2 times 0 goes away. So you're left with y is equal to 15. Sorry, negative 15. Right? So you would say your y-intercept is negative 15. Okay, now if you wanted to, you could say, you could say this, or you could give the point. 0, negative 15. And there we have it. That's one way to do it. Okay? Now the other way would have been to just say, hey, recognize that your equation is in this form right here. And then say, you know what? Forget it. We know that our y-intercept is negative 15. Boom, we're done.